Hello, my name is Jack Wallace. This is my presentation, Dancing with Blender, my personal contributions. I'm part of Team B, and I am the project leader. Here's my table of contents. We're going to go through problem/objective statement, followed by summary. Then we're going to review milestone presentations. We're going to look at team structure, robotic assembly overview, design solutions and details, closing statements, and we'll have some references at the end. So our objective statement. We are looking to achieve live control and animation of the physical robot using Blender as a digital controller. And the live control is going to be a manipulation of the robot itself within the software reflected in the actual robot, in real time. And we're going to be making this robot using 3D printed plastics, servo motors, hardware, and the software is going to be Blender as stated previously. And we're going to be using Arduino Uno as our microcontroller. And we went between two different add-ons for the software, which was Marionette and Servo add-ons. Both were pretty promising, but we ended up going with the Servo add-ons because they were supporting our driver setup automatically versus Marionette. We had to do a lot more software manipulation and coding to get the drivers to work, because Marionette was originally designed to only be used with the Arduino, not using the drivers. So, our project summary. We're going to develop a mini-plan V6 robot using 3D printed ABS plastics, Arduino programming, 19 servo motors, and Blender software. Blender is used to create the virtual animation that will be uploaded to the physical robot via servo add-ons and some small code modifications. Live control is also going to be supported through the virtual assembly manipulation. So here's some of our milestone review information, and we'll go through a couple of decision matrices. So for milestone 1, we created our team structure, and the problem/objective was identified and defined, and some research was done. 3 decision matrices were used to help make decisions on the solution process, and the best option was chosen. The solution that was chosen was compared against 2 products that were already on the market. So as far as the team structure goes, I volunteered as the team leader. No one else wanted to do that, so I volunteered. As far as the problem objective, that was also developed by myself and Taylor within our group. We did a lot of the presentation work and the more, written kind of work for this project. And the background research, when we first were given this project, I did a lot of background research, and I was the one that originally found the Marionette software add-on and thought that was the one and only, as well as the best solution for using Blender as a controller for the servos, because Blender's naturally just a animation program. It's not designed to be a controller, but Marionette's had some promising results on YouTube, and there was a GitHub link that ran through the whole process of using it. And so we ran with that initially, and then after some time we talked to Professor Choi, and he introduced us to the servo add-on path, which we eventually determined was going to be more streamlined and easier to adapt because of the driver issue that we were having with Marionette. But so I did a lot of the initial research for the, using Blender as a controller, and I handed that off to Mason and the software/programming team, and they were the ones that ultimately helped us come to the decision of going with the servo add-ons, because we pursued both servo add-ons and Marionette for about a week or two, and we just after using it for that amount of time, we were able to confidently say which one was going to be our easier solution, although we did believe both solutions were possible. the servo add-on just seemed a lot more promising and more streamlined. The decision matrices I helped develop, and there was a specific one that we'll get to in a second that I did. And yeah, some of the solutions that we compared our solution to, I looked into as well. So this is one of our decision matrices from milestone 1. And okay, well, this is another one from milestone 1 as well, table 2. This one is table 3. As you can see, the total weighted score on the past 3 diagrams, the highest weighted score is going to be the solution that we went with. And we took a little bit of research to confidently say what we were going to rate each individual criteria for each decision matrix option. But that was some research that I did myself with a couple other team members. So this is our team structure. As you can see, I'm the project lead, and this was honestly kind of like a voluntary, decision. Everyone kind of just volunteered. Well, maybe not, with the exception of maybe Sean. I kind of threw him into the sub-lead position just because he was pursuing the Blender animation and the servo add-ons. I'd say the most. Followed by Mason, who's doing the marionette integration, who's also, recently now helped out with the servo add-ons, and he's done a huge amount of work, and he's been a great help. And Jacob's been doing the wiring for the whole system. But I kind of just nominated Sean as the sub lead just so we could have someone to to talk to and see the progression of the project itself and have a leader for that subgroup. Then we have Chris as a sub-lead for hardware, bill of material, and printer operations. Travis was part of the disassembly and robotic testing. Chris, I also nominated as the sub-lead for the same reasons, to have someone that I could reference to catch up with progression of the project and see how things are going. And then the rest of us were all honestly more just like general workers. We did a lot of the milestone presentation work, and we kind of did some, smaller tasks that the sub-lead, Sean from the Blender animation team would request, because I would say he probably had the majority of the workload. So this is a more detailed representation of everyone's role and their responsibilities. It's basically everything I just mentioned earlier. You can take a second look at that. So this is our assembly itself. And this, I did not put this together. This was the assembly team. But I did, check in with them and make sure that they were on track to finish with time for our sub-team for the Blender integration to have sufficient time to test their Blender controls. And this team ended up finishing their build process before time, and we had plenty of time for the Blender team to test their results. This is a wiring diagram that I helped with Jacob. So Jacob did most of the wiring, and I just oversaw it for the most part, and I just stood by and I would assist him if he needed any materials, whether that's wires, shrink wrap, cable ties. If we burned a driver, I've gotten a couple new drivers and gotten with Professor Choi as far as, resoldering those drivers to the same standards of the previous. We've burned through a couple servo motors, so I've had to go scavenge for some servo motors. We've tested multiple Arduinos, so I've just been a support as far as getting all the materials and just talking Jacob through some of the decisions he's making and being on the same page as him, so that I'm up to par with what we're doing. This is our control review. So as mentioned earlier, we were thinking about doing Marionette at one point, and ultimately decided not to. Marionette was my initial pursuit, and I introduced it to Mason, and Mason, fully pursued that solution process, and he did a great job. And he was able to eventually get a driver to work with the servo motors and Marionette. But it was just going to be more difficult to continue to add more servo motors to that driver and all work in sync with Marionette when the servo add-ons were designed to be used with a driver. So ultimately we just went with the servo add-ons. So this is a video, won't be able to play it on the recording, but basically it's just representing the servo add-ons and the live control. If you move one of those armatures on the screen, it'll move in real time on the physical robot's joints. So this is just the control process for Blender. For the Marionette, as I mentioned earlier, there's the GitHub link that ran us through the whole process that I found via YouTube. And for the servo add-ons, we were given that by Professor Choi. So Blender is used as a controller, and I did some pretty good research and watched a lot of YouTube videos on the animation process and how to build a assembly within Blender. And I initially pursued that process as being a big role on the animation team, but due to constraints on my laptop, I wasn't able to run the Blender software very well, and I ended up not being able to create an assembly without the Blender software crashing. So I ended up just working with the teams, Mason and Sean specifically, and we ran through the whole process together and looked at, how to build a full assembly, how to upload a STL file, and add these bones within the STL file that, correspond to each servo motor. And with that correspondence, you can manipulate the full assembly within the software, and it'll move the respective servo motor on the actual robot itself. This is another video of an animation, which I don't believe it'll let me play either. But this one is just going to show the leg moving, not in real time, but with an animation. And this is, one of our older videos where the animation wasn't a one-for-one ratio perfect depiction of the animation in real life. But it was, just a good starting point for us. And I helped Sean out with this one because initially we were using a full STL model on the Blender software. So as you can see in the image depicted, there's the laptop in that image has some bones in there. Those are the bones, aka the armatures. Well, initially we're using those inlaid inside of a STL file of the actual robot itself, and we're having a lot of issue manipulating the robot and the armatures in sync. So I suggested that we just get rid of the STL file, start from scratch, and make a simplified bone structure without, the STL file representing the robot, and we would just see the bones. And that's what we did here, and it worked. And this was one of our first successful animations. Definitely needed some work, and we wanted to ultimately include the STL file so you could see the robot within the Blender software. But it was definitely a great start. So the robot currently moves in real time, and it moves together with an animation. We're having some issues with the application of power and servo motors locking up, but we've just recently solved that issue, and we have our servo motors set to a 0 position, and we're not having that issue anymore. So this is what our ultimate goal is and what we've recently achieved. We have a full STL file, which you can see the gray robot with some armatures, also known as bones, inlaid within. So this is the Marionette process, which we ultimately decided not to go with, but it had some promising results. So in conclusion, working as a project lead led me to manage some sub-teams and beat deadlines and create a high-quality product. Supporting all teams with a concentration in software development was my main role. Software development was the most demanding role, or I say the most demanding sub-team. They had the most work because the software was most difficult. There wasn't, a great set of instructions to follow for our specific application. Um, I offered a lot of practical solutions that we experimented with. Some of them, we went with in our final product. Some of them we didn't. For example, Marionette, that one we didn't go with, but another solution that I offered was getting rid of the STL file and working with a simplified uh, bone structure to test our animations, and that one worked great and it got us on the right track. So I also developed a lot of team report documents and kept up with individual contributions. So all of our Drive folders, most of those were developed by me, and our daily report logs was all developed by myself. And yeah, but those are pretty straightforward, and everyone contributes to those in their for the individual reports. They can go in there daily and put their individual work in. I just created the format and organized it and made sure that they were submitted on time. I also did a lot of development for presentations from MS1 through 2, and then now currently working on Milestone 3. And I gathered a lot of materials and discussed requirements with leadership, specifically Professor Choi. Talking with him, getting his assistance with some soldering and his, knowledge, and requesting what he thought would be the best route to take for troubleshooting, as well as looking at our, milestone 1, milestone 2 presentations and getting feedback from him, what we did good, what we did bad, where we can improve, and he was a great help. And then finally, just leading individuals who do not know how to contribute. Some people, given the reality of programming was our, largest tasks, but we only had 2 computers that could reliably run the Blender software. We had a lot of people who wanted to contribute but weren't able to contribute to that high demand. And uh, I just had to, find some work for them to do, which ended up being a lot of milestone presentation work and yeah, a lot of documentation and working towards creating quality presentations, and for our final submissions, our our advertisement, and our brochure. These are some references, and that's it.